Hello, everyone, and thank you for attending today's webinar, Blockchain and the Enterprise, but what about security? My name is Emily, and I'm a member of the Hyperledger team here at the Linux Foundation. Before we begin, I want to cover a few housekeeping items. First, this webinar is being recorded, so if you need to drop off at any point, we will automatically send you a link to the recording via email within a day or two. At the bottom of your audience console are all the widgets that control the movable and resizable content windows. You can click and drag the lower right-hand corner of each widget to change the size, and you can move the windows around to customize the layout to your preference. Starting with the icon on the left, the red film rail controls the audio for this event, or it allows you to fast forward or rewind if you're watching this on demand. The Q&A widget allows you to submit questions at any time during the presentation. We will try our best to answer as many of them as we can. If you're watching this on demand, you can still submit questions and we can respond to you via email. The chart icon controls the slide viewing window. The document widget contains links to resources we hope you'll find interesting, as well as a copy of today's slide deck. The person icon opens a window where you can learn more about today's guest speakers. The clipboard allows you to access our survey widget, which helps us collect valuable feedback. Please take a moment at the end of the presentation to answer a few questions about today's session. And finally, the question mark opens a help topic window in case you experience issues with the console. If you're joining us on a non-Ubuntu Linux machine, please keep in mind you may experience lags in slide advancement, and refreshing your browser might help. You can join us on Twitter using the hashtag LFWebinar, and don't forget to follow us at @Hyperledger and @Linux Foundation. As I mentioned, keep an eye out for an email from us in the next day or so with a link to today's recording. That takes care of our housekeeping info. I'm pleased to introduce today's guest speakers. Today we're joined by Dave Huseby, Security Maven, and Marta Piekarska, Director of Ecosystem here at Hyperledger. I'll let them tell you a little bit more about themselves. Thank you so much for joining us today, Marta and Dave.
Thank you, Emily, and thank you everyone for joining us. We really appreciate your time. My name is Marta Piekarska. I am Director of Ecosystem in Hyperledger for basically all my life. Since I started studying. Today I'm very excited about blockchain and what it can bring to enterprises. Dave, can you tell us something about yourself?
Yeah, hi, I'm Dave Huseby. I'm the Security Maven at Hyperledger. I get the question all the time, what a Security Maven is. Briefly, I think I'm in charge of all the security-related things with our blockchain projects, doing bug bounties and security bug report handling, and also coaching our teams in secure software development best practices. I've been in the open source industry for going on 25 years. Yes, really, like since the mid-90s. And for the last decade or so, I've been focused mostly on software security and how to write better software. So with that, Marta, would you like to start?
Thanks, Dave. Yeah, so you know how it goes. Orange is the new black, blockchain is the new black, all blockchain sprinkles. But let's start with setting up some ground for what we understand and what we should know about blockchain before we dive into security. We started exchanging good and trading a long time ago. First long-distance transaction occurred between Mesopotamia and Indus Valley in Pakistan 3,000 years before Christ. There is an implied need for people to interact. We are social animals, and I'm better at having more bread. You might be better at getting more peanuts. So we need to exchange those goods, and we need to exchange value in order to live in a society. Question: how do we agree on asset balance? How do we track value of those exchange goods? If I give Dave 2 loaves of bread and in return I get 1 fish, obviously I'll try to be cheeky and sneaky and move that from get for the next 1 fish 5 loaves of bread. So how do we agree how much 1 loaf of bread is worth in the end, and who owes whom how much? Traditionally, we've done that with ledgers. Ledgers as in books that keep track and record of all of the transactions that we've done. Either the traditional ledgers were probably on clay slabs, then we moved to paper. However, paper is very volatile. It gets destroyed easily, and leave them behind. And that way, the whole history would be completely destroyed. That's why we moved to digital world. However, you all probably know that any digital file can be copied, and I bet all of us has some experience with copying data of the internet and downloading it and so on. So if I copy a file, I can also change it, and now we have a problem, because how do we agree what is the ledger, what is the some common single source of truth? Well, there is an answer to that. It's the internet. With the introduction of internet, we were able to create peer-to-peer networks where we could keep our ledgers in sync and create network of independent nodes where each store a copy of that ledger. Every time a new transaction, new exchange is created, people can announce that and try to achieve some kind of a consensus. What is the real thing? What is that value that we now want to store in our ledger? Of course, the question is, how do we agree on that? What is a good so-called consensus mechanism? That is a different question, and that is what will bring us to enterprise solutions. So that's why people love blockchain, because these are the potentials of that fairy dust you all have heard of, and why we are all asked by our business developers, oh, please, let's move to blockchain. Enterprises love blockchain because it's a technology, and I can't even stress that enough, far beyond what Bitcoin has to offer. Shared ledgers, network nodes can generate and verify data generated by the others. So we don't have to rely on one source of data. We can store the historic record of verified transactions that is easily auditable because it is accessible anytime, anywhere. We can create distributed consensus mechanisms that eliminate costly and inefficient reconciliation processes. And as I said, there are many consensus mechanisms. They have better or different qualities. However, there is never one central repository, or there shouldn't be one central repository, which means that there is no single point of failure in case the network goes down. You have to take down a big part of that network to actually destroy blockchain. It is resilient to that network power and cryptographic integrity, and there are large economic disincentives for malicious actors to play. And I guess this is simple now and easy to understand why World Economic Forum published a white paper where they predicted that by 2025, 10% of global GDP will be assets tracked and traded using blockchain-based distributed ledgers. It's incredible. 10% in only 7 years from now. That amazes me, to be honest. But it is we recognize that. I've been in that space for 4, maybe 6 years, and still don't quite grasp it all. I hear words, and these words quite often seem to make sense, but then when I dig deeper into it, I can't quite understand it. And that's why with Dave, we created this cheat sheet for you. So I promise you, Google those 25 words, and you will be, and obviously memorize what they mean, and you will be able to have a fairly decent and informed conversation with anyone about blockchain. But as I said, blockchain is complicated, and although everyone loves blockchain, they also have very hard time sometimes understanding what are the different challenges. So Dave, can you take us through some examples of what blockchain security is?
Yeah, thanks, Marta. You're right that blockchain presents us with some new challenges due to their decentralized nature. Let's take a look. Have any of you heard of the Bitcoin graveyard? If you haven't, I suggest that you take a look at it. It's an analysis website that takes, or that goes through all of the known publicly announced hacks against Bitcoin websites, Bitcoin exchanges, and other cryptocurrency implementations. And I wanted to show you a graph today that breaks down the nature of the different kinds of hacks. But I'd like to call your attention to the fact that the number of hacks against the protocols themselves, the computer science that makes distributed ledgers work, is very small, and it's the column on the far right. The rest of all of the hacks are focused on implementation details with servers and with handling of credentials and cryptographic keys. And what that has led to is something like this with Japan's CoinCheck company. This was current year. This was in January of this year. The largest crypto hack in history took place against really just the user's wallets. This was an implementation detail that went wrong, and it allowed an attacker to penetrate the server and to steal for $530 million worth of their cryptocurrency. And this highlights sort of a fundamental shift that we're seeing in as we move from centralized systems to decentralized systems with these distributed ledgers. Traditionally, I would say, traditionally is kind of a funny word to use in technology because things change so rapidly, but traditionally we've had these centralized systems where people use usernames and passwords to log into a system, and a central server would then grant them the capability to do certain things. And anytime they would, say, try to upload a file or download a file, the centralized server was checked with their credentials to see if they could download or upload the file. Now, moving to decentralized systems, we have to come up with a different way of handling authentication and the capabilities of users. There was a paper written by a computer scientist named David Chaum back in the 80s that suggested that public-private key pairs could be used as capabilities. Possession of a private key could be all you would need to be able to do a certain action in a distributed system. And fast forward to today, all cryptocurrencies and all distributed ledgers are based on this idea. It's a fundamental shift in the way we think about security, and the primary consequence of it is that it pushes security to the edges and makes the key material a high-value target. And that's why we see a large number of cryptocurrency hacks happening against exchanges. Exchanges are servers that concentrate the key material for all of the users, the people who possess the cryptocurrency. So what we learned from this is that when you're talking about security of distributed ledgers, you have to look at the whole picture, right? We've based these systems on very solid theory, but this is one of my favorite quotes by Walter Savage. In theory, there is no difference between theory and practice, but in practice there is. So as we build out these systems, we need to recognize that basic security matters, right? And that the user-centric security matters. We're moving away from a simple username and password system to every user having to own and manage this high-value key material. And there's a whole industry developed around this with hardware wallets and key escrowing and hardware security modules and all these things. And we've also done a lot of research in key splitting and key signing keys and HD wallets and all these new technologies that are being developed to try to solve this problem. But it's certainly a work in progress, and the user experience in many ways has gotten worse. I mean, if you think of an unsophisticated user coming to one of these systems and suddenly they're presented with, here's your private and public key, now don't lose it, because if you lose it, you can't participate, you lose all of your cryptocurrency, and you can't store it to disk because if anybody gets it, they can just steal all your cryptocurrency and there's nothing you can do about it. So you can see that the security challenges are immense, but they're all concentrated more on the end user. And that's sort of the world we're moving to as we deploy all of these blockchain-based solutions in all of these different industries. But one thing that I want everybody to remember is that we already know how to secure servers, how to secure data at rest, how to secure data in motion. And I would argue that 95% of blockchain-based solutions, distributed ledger security is something we already know. Using firewalls properly and protecting data at rest using encryption and all of those things. So there is a spectrum of solutions that are coming out of these distributed ledgers, and just, everything you know about basic security in your industry still applies, so don't panic as they come into your industry. And at Hyperledger, we're very fortunate to have hundreds of corporate sponsors that we have been able to learn from. So, Marta, can you talk us through some of these solutions from our partners?
Well, yes, but first, let's talk why blockchain for business. How do you actually use it? It's up to you. But there is a spectrum, and we know today that there won't be one blockchain to rule them all. So why? Because for every use case, we need a different model. And let me give you an example here. Of course, there is the permissionless public network like Bitcoin or Ethereum, where anyone can write to that blockchain and anyone can read from my blockchain. However, on the other hand, in case of, say, medical records, do you really want to have a situation where anyone can access your medical records, and if you didn't have a nice meeting with someone, they can simply just add a bit of hepatitis C to your medical records because they can access it? That's why we have that spectrum where permission versus permissionless, a blockchain, and private versus public is about visibility, who can read from a blockchain. In the middle ground, we have a lot of space to develop. For instance, for land titles or university degree, it is a great use case to have a permission but public blockchain, where only certain people, like the registry office or university, are able to prove that or submit information that you have actually graduated from that university. But on the other hand, anyone can go and verify, was their solution like that, that I have obtained a PhD in computer science from Berlin University. So we need those different blockchains. And we can see very clearly, depending on the industry, the ask and the adoption rate, deployments today are different. And if someone's telling you that you are too late to the game, you're not. It may only really mean that you haven't joined the Kool-Aid crowd yet. Definitely looking at it today, we can see that supply chain, and healthcare could be named the early adopters. In these industries, we see today in 2018 late POCs, maybe first deployments. Financial technology, on the other hand, and I specifically mean fintech and not just cryptocurrencies, because we want to stay shy away from that, has been in the innovators curve. They have definitely been deploying and developing, and today we see some extremely interesting consortia being built on top of permissioned blockchains. And then we have early majority, like logistics, insurance, and governments. It is incredible to think that today there are 203 different government use cases and projects around the world, all the way from Americas to China to through India and all across Europe. Governments are investing in blockchain, not to mention Smart Dubai that has a whole system and plan to move fully to blockchain-based solutions by 2020. But truth is that we, the technologists, the geeks, think that we can solve it all, and we can't. It is like that old XKCD that I really, really like. Blockchain will not solve all of your problems. In fact, it may actually create more problems than it solves in some cases. And blockchain is not an answer to all of your problems. So tell me more, Dave. Tell me, what are the challenges of enterprises face in adoption of blockchain technologies?
Sure, Martha. Let's get onto the right slide here. Oops. There we go. Yeah, there are a whole host of problems that come along with doing decentralized ledgers, distributed ledgers in the enterprise, but I'm going to focus on one today for the most part, that being the most obvious challenge with enterprises being top-down centralized organizations that are used to controlling who can and cannot get access to their computer systems and what everybody can do. You have a very role-based centralized management system. And now we're asking these enterprises to shift to these decentralized ledgers where you have multiple organizations typically coordinating across their normal firewall boundaries and sharing data and trying to like de-siloize their business operations. I mean, if you can think of like a vertical in an industry where you have a producer and a wholesaler and a retailer, we're asking them to start sharing data in real time and a lot more data than they traditionally have. Enterprises aren't designed really to collaborate other than what their normal formalized paper-based collaboration tools are. And when we move to these decentralized systems, suddenly things get a lot more efficient and a lot more data starts flowing. And there's all these challenges around protecting your intellectual property, protecting the operational advantage and intelligence. If you go back to my example of a vertical where you have a producer and wholesaler and retailers, if you have multiple wholesalers, multiple producers, multiple retailers, how do you get all of them to cooperate on a decentralized system and still allow for, say, a wholesaler and a producer to negotiate a different deal than that same wholesaler and another producer? Like, how do you, that's the prices negotiated are actually operational secrets because that data then moves forward in time. That information moves forward in time and becomes a competitive advantage. Like a retailer can offer a sale because they got a better price from the wholesaler negotiated a better price from the producer. Now, if all entities in this vertical are on the same blockchain, how do you protect that kind of confidentiality? Well, Hyperledger blockchain networks are designed to not only distribute the load and spread out the risk and further this collaboration, but also to protect the confidentiality between parties on this blockchain. Open source definitely helps. I mean, we're building a platform with lots of eyeballs on it, and I spent a lot of time worrying about how to make that platform secure and solid and something that people can trust. And yeah, I mean, we at Hyperledger think that the open source model is the way to go. I think it was true for the web and web servers and web browsers, and I think it will also be true for the blockchain. The one thing that we need to know is that it really is important to be earnest. Like, we all want to make the world a better place. We all want to have nice things. And so doing the open source thing and doing correct responsible disclosure systems are hard when you're in these decentralized and anonymous networks. And what we want to do is develop ways for us to collaborate on these. The consortium model is coming up as the best practice. We're seeing lots of networks where members of a certain industry either use their industry group or they form a new nonprofit that they all become members of to help coordinate that level of cooperation. Now, we do need to know, or do need to remember, that these are decentralized systems, and denial of services, decentralized denial of service attacks are a real thing. The consensus networks at the core of these networks need to be protected. You can think of the security for these blockchain networks as modeling or being very similar to n-tier architecture for websites. You have API servers that clients of the network interact with, and those can be thought of as sort of your front end reverse proxies in an n-tier architecture. And then we have transaction validators and transaction and the ordering system, the putting transactions into blocks. That's sort of your middleware, your mid-tier, and then the consensus network where blocks get voted on and distributed as sort of your backend. And so the same kind of security applies. Your consensus network should be definitely behind the firewall. But then how do you solve that when you want everybody on the, every participant in the blockchain to control a node in that consensus network? And what we're finding is what is old is new again. Back in the day, in the late 90s, when we wanted to do high-speed high-speed collaboration between companies online, what they would do is lease servers in the same co-location and just literally run Ethernet through the chain link fence between their servers. And that's not a bad idea today for these decentralized, or for these consensus networks, because latency dominates the upper bound on transaction throughput. The other thing to consider is that smart contracts, when you're encoding complicated business logic, are really only as smart as their authors. If the smart contracts are flawed, your overall blockchain, your overall distributed ledger system is going to be flawed. I mean, we saw this in the DAO hack, right? It's really important to make sure that your smart contracts are simple and straightforward and get reviewed and tested before putting them into production. So it's just like we've always done with servers and with software in general, is you just need to be cautious and to assume that something's going to be wrong, and to try to break things down into their simplest pieces so that you can understand each of them well, implement them well, and then compose them together to make more complicated solution. And with all of these problems, you would think that enterprises are having a hard time deploying these, but it's not true at all. We're seeing a lot of enterprises in a lot of industries moving over to distributed ledger solutions and deploying them in everyday situations. So, Marta, are you going to sorry, you talk to a lot of our corporate members and people deploying our technology. Are they really getting value out of this? Can you go over some of the real-world examples?
Absolutely. Absolutely, Dave. They are getting a lot of value. With 250 members in Hyperledger, we are really lucky to observe the wild west of permission ledgers and blockchain. And I can tell you that really sky is the limit. You can be as open as you want or as caved as you need to be. Interestingly, there are, in my opinion, kind of two categories of solutions and deployments that I see today. In one, is there as a part of a whole solution, whole system, doesn't necessarily increase security, and quite often quite the opposite. It actually means that you have to have yet another layer of security. So blockchain becomes part of your traditional legacy solution that improves other elements of the system, but it doesn't quite improve the security. And then there is another layer where it becomes, when blockchain becomes your security assurance, it increases your security. So same technology can be really used both ways. Let me go through two examples, and I know, Dave, that you have one that you really want to talk about, so I'll let you do that in a second. Let's look at both ends of that spectrum or that transaction. Change Healthcare of Hyperledger has created a claims management transparency system between the payers, providers, and other parties. It is very interesting here to observe that basically blockchain is maintaining the real-time immutable record of claim lifecycle and is being kept as a verifiable and trusted root of truth. Let's say it that way. So submits the claim to the claim network that then immediately uses blockchain as being that kind of a real-time immutable record of claims. Then through that same network, the blockchain can trigger an event on the claims network workflow activity, allowing for the payer to now see that there has been a claim that has been submitted. And again, payer looks at that claim and can be then verify with the provider to or pass over the claim to the provider. And provider can access the claim status from the blockchain through an API. So it all concentrates around blockchain. Now, the question is, how do we secure a system like that? It is no longer the case that we have to just worry about all of those different parties being secured. But we have a much bigger problem, which is that our blockchain network is secure and that what goes onto that network is verifiable and true. Because blockchain is garbage in, garbage out. If we all agree on something that is not true, or we accept a transaction that is not true, then we have a problem because we don't have a way to remove that transaction. And now everyone is informed about fake news, basically. So this is why blockchain really has to be secured, as well as in addition to all of the claim networks and how payer is doing or keeping what payer is keeping on their servers and provider and so on and so forth. On the other hand, we have a very different solution. This is an amazing example of also how blockchain brings collaborators together. Companies like Chronicle, Thales, and Accenture to create a secure supply chain solution. You know, traditionally in a supply chain, you pass information from manufacturer to the OEMs, to the buyers, to the customers, all one for the other. But this is not really very cost effective and not very secure. So what these three companies did is they joined forces, and Accenture integrated the technologies deployed to demonstrate how blockchain and smart contracts can be used by OEMs and suppliers. On Thales' side, they have created modules that are now using hardware and software-based FPGAs. And these modules have been integrated have integrated Thales IP to enable the registration and validation of FPGA models using the Thales physical unclonable functions capability, which obtains a unique identity for silicon chip using embedded software. And finally, Chronicled provides a solution where supplier can secure batches of their product using crypto seals. And these provides a secure and tamper-proof mechanism for suppliers to provide companies meeting the specification of the order and record the attributions on the blockchain to enable the reconciliation and problem solving downstream. So this is really, really interesting for me. And I really like this example because now you can see how a simple collaboration between an HSM and a manufacturer can all be combined together. And then there's the third use case. And Dave, I will let you talk about that one because it's very exciting.
Thank you, Marta. Yeah, you can tell you're a real nerd when you, like myself, when you get really excited about access control systems. Our third use case is actually about what I was speaking earlier when I was talking about how key material becomes a high-value target in these decentralized ledgers, and that security is pushed out to the edges, and it becomes the responsibility of the end user. This last use case comes from a member of Hyperledger called Hasera, and they have developed a really, really clever way of doing key escrowing on the blockchain in a way that mimics your normal centralized enterprise key escrowing process. And by key escrowing, what I mean is in a traditional enterprise environment, you have a centralized access control system. You know, you have a new employee come in and you have to set up their account and issue them the credentials to access the services, internal services that they need to execute their job. Well, in the decentralized environment, you were pushing that management role out to the edges as well, and that really goes against the grain of many corporate policies. And so Hasera came up with this really clever solution where you have a system administrator who is able to manage the members or the people able to access the blockchain and to interact with the different APIs and submit different transaction types. They can manage it in more of a centralized role. However, the issuance and revocation of those credentials is validated by the blockchain and distributed in the ledger. And so all participants on the ledger can track the access control system. So the most clever part about this is just a general protocol, and it's blockchain agnostic. So their first demonstration of this won them an award at a Hackfest where they took Ethereum, Hyperledger Sawtooth, Hyperledger Fabric, and by the way, Hyperledger Sawtooth was running the Hyperledger Burrow engine, which actually runs Solidity contracts. And they used it to demonstrate people coming into this system, participating and having different roles. So anyway, this becomes like a third role, a third way in handling the credentials and access to these decentralized systems. So it eases the transition of bringing a distributed ledger into an enterprise or into a multi-enterprise organization and still allowing the enterprise IT staff, administration to manage the access in the way they're most comfortable. It's more of a centralized way. So there's you get a dashboard and all these things, and everybody can see credentials being issued and revoked in a transparent way. But the only people who can see it are the administrators. So anyway, it's an extremely clever way. It was a brilliant solution for bridging the gap between the centralized and decentralized world. The centralized world of the past and the decentralized world of the future. And I'm just super excited to see this. I think it really opens up a world of possibility, and not just for Hyperledger users. I mean, this is a blockchain agnostic solution, so it definitely can be used in enterprises that are basing their technology on the Ethereum network and building their logic around that. So I hope this really gets you excited as much as it does me. And Marta, I guess we're moving on to the wrap up.
Yeah, we are coming close to the final, but let's summarize it. You came, you've seen our presentation. Now, we both have some action items for you. No matter if you're a technologist or a designer or a CEO of a company, just remember, blockchain is just a tool, and we have to design our solutions well. So short term, what you can do is you can remember that old security measures apply. And there are new ones that you also have to remember about. Go and revisit your security models and architectures. Look at new problems that blockchain may introduce to your companies, as well as places where it will solve your problems. Then, in a couple of months' time, or throughout the next couple of months, start remembering and thinking about usability, because designing systems with usability in mind might be one of the most important things you can do for security of your enterprise. Ease of use will be what will decide if your solution gets broken or not. Because truth is that most often it is the users who breach security, not because they are stupid, but because we didn't design the systems well. And long term, let's remember, collaboration matters. Rethink whom we should be working with and collaborating with, and start doing it. Because blockchain is really a peer-to-peer network, and we need peers. And I know that many enterprises tell us that they are not comfortable with sharing information on the blockchain. But that's why we have privacy solutions that improve that. And we have to get comfortable with blockchain. And the real question, or the real thing, is that you can help. So Dave, walk me through, how can I get involved with Hyperledger?
Yeah, thanks, Marta. There are things that you can do right away. Hyperledger is an open source organization, which means that we are an open door. We're a big tent. Everybody's welcome. The first thing I would like to point out, because I'm the security maven and I have a privileged position here to talk to all of you, if you think you find a security bug, anything that looks like you can bypass the built-in security, or you got it to do something that you didn't know or that you think it shouldn't be able to do, I encourage you and I ask you to report it to our security@hyperledger.org mailing address. It's our confidential security bug reporting system, and we have SLA policy around this, and we do have a bug bounty. So if you find anything that's serious, we may cut you a check. That's the easiest thing you can do. And if you're really more interested in our bug bounty and wanting to participate in a more active role, HackerOne has been generous enough to host our bug bounty and to administer our bug bounty for us. So if you go to the hackerone.com/Hyperledger page, you can read all about our bug bounty and our payouts. It has been successful. We have had a number of security reports through our bug bounty, and our products are better today for it. If finding bugs and tracking bugs is not your thing, and if you're more interested in how our technology can apply to your industry, you can join any one of our working groups. If you go to the wiki.hyperledger.org webpage, there are a number of working groups in different industries listed there that you're welcome to join, and I encourage you to do that. They're very open and very friendly. They have regular meetings and discuss industry-specific applications of our technology, and it's probably the best place for somebody new to Hyperledger to learn about sort of where the state-of-the-art is in your particular industry. The other thing I'd like to point out is if you want a more high-level introduction into, well, actually, it's not high-level. It's an hour long and all the possible ways to get involved in our community. I recommend watching this webinar by our colleagues Tracy Kurtz and David Boswell. The link is here. It's a fantastic webinar. So as you can see, I mean, like all open source projects, we live and die by the community being involved, and the community is you. So I encourage you to come and hang out, if anything, and help write code or help play with the software or find bugs or, you know, just come and meet friends. And with that, let's see. Martha, you want to move on with our recommended reading?
Sure. We put together some resources for you because, as we said, this is a terribly complicated space for now, and it's still early days. Places to seek for interesting reading, it's here. So these are papers that we've published through Hyperledger, and some of the on a more broader technology. So just click on the links and enjoy reading. I would like to mention one more thing. We are organizing a Hyperledger Global Forum this year. It is very exciting. It'll be our first conference this year. First conference ever organized by Hyperledger. We expect very big attendance, both from technology and business side. We have call for papers out, so if you'd like to submit a paper, please feel free to do so. We will be meeting in snowy and cold Basel, but I promise you that there will be very warm and heated discussions there. Developers will come together, and you have an opportunity to speak at a global forum. So please just submit a proposal by July 13, and you can use that link on the slide here to go to it. This brings us to the end, and I thank you for your attention, and we will be very happy to take some questions now. David, do you have a question that you picked? I'm looking here at questions. Do you have a question that you would like to answer first?
Sure. There was one here I just answered. It was one that I get a lot. Let's see here. So I'm just trying to find it. Where was it? Oh, okay. So the question is, certain people familiar with blockchain argue a blockchain that is closed off defeats the purpose of blockchain. I wanted to understand, what do you think of that statement or thinking? And the person says, by the way, not my thoughts at all. So the answer that I posted here, which I can't read for some reason, but the answer is that my counter argument with this is that cryptocurrencies that are closed off defeat the purpose of cryptocurrency. But it's a good thing that cryptocurrencies are only one of many, many, possibly infinite number of solutions or applications that could be built on decentralized ledgers. Yes, it's true that the permissionless public blockchains make a really great platform for doing currency, but currency of its very nature needs to be decentralized and trustless. And I would argue that the rest of the world is a permissioned world. The relationships between any two businesses or people with businesses is a legal one. It relies on us knowing who the participants are. I mean, know your customer laws are a great example of that, or anti-money laundering laws, or just simple contract law. When you want to do a private sale of an automobile, you draw up a bill of sale. That's a contract permissioned situation. And so Hyperledger blockchains accept that reality, that the world is based on us knowing who the participants are and having some contractual arrangement to participate in the system. And we built a blockchain that can leverage that. I mean, decentralized ledgers really are about transmitting trust and about tracking the provenance of digital things as well as physical things. And I don't think it matters necessarily whether it's a permissioned or permissionless blockchain, other than looking at the specific application and seeing if that's an attribute that's required. And most applications, permissionless, the permissionless system is not necessarily required. In fact, it's the opposite of required. I mean, a lot of systems, we can't have anonymous participants or, business transactions where there is no contractual arrangement. So I think the argument is narrow, and it's really more about cryptocurrencies than blockchains in general. So I hope that answers that person's question. Marta, do you have one you'd like to pick?
I picked three that I think it would be great if we could all answer. Here, one question that is very interesting, and it will be short answer. Do we have any publication on performance metrics for assessing Hyperledger blockchain? So dear Pramod, yes, we do. We have both a white paper that talks a bit about Hyperledger, as well we have a performance and scalability working group that you're more than welcome to join. They meet every 2 weeks. All working groups in Hyperledger are open to public, so you are allowed to join those teleconferences. There is a calendar available on our community, on our wiki page, where you can check when they meet exactly. As well as there is Hyperledger Caliper, which is a project that is supposed to look at the different frameworks in Hyperledger and create a way of measuring their performance and scalability. It is not to compare these frameworks, because you can't compare apples and pears, but to say in this given circumstance, this is the maximum scalability, or this is the maximum performance I can get from that particular framework. So then Tessa here asks, what are the main Hyperledger platforms are being looked at or used by industries today? We see a wide adoption of all of Hyperledger platforms. Hyperledger Fabric, Hyperledger Sawtooth, Hyperledger Iroha, Hyperledger Indy, and Hyperledger Borrow are all very widely used. It depends on the industry and it depends on the use case. Indy will be definitely mostly used in identity space. On the other hand, Hyperledger Fabric and Hyperledger Sawtooth are both great when it comes to basically any sector. We see Hyperledger Sawtooth deployment in music industry. We see it used in fashion industries. Obviously, food supply chain is a big use case where you can see deployments both in Hyperledger Sawtooth and Hyperledger Fabric. While Hyperledger Iroha is really interesting when you want to build solutions that are running on mostly mobile devices. And that's why Hyperledger Iroha is mostly used in these cases. I've even recently seen a very early POC on bringing blood donations or delivering blood donations with drones with the usage of Hyperledger Iroha. So Dave, your chance to answer a question.
Yeah, so I'm going to do a quick fire. So I had one question saying, hey, we've talked about the different structures of, how permission blockchains are structured differently than like Bitcoin, for instance. I wanted to point out, for those who want to know more about the technical architecture of our platforms, there is a great course on edx.org. It's Echo Delta X-ray.org. If you go to that website and search blockchain for business, there's a really great course there on the introduction to Hyperledger technologies, where we go over setting up networks using each one of our main platforms and about how they're technically organized. And then moving on, sort of the follow-on point here is I've had several questions about, like, what is the possibility of playing around with different consensus mechanisms, and like what is different in the architecture that makes Hyperledger interesting, and Genesis blocks. I'm going to try to answer them all in one answer. So Hyperledger distributed ledgers are broken up into several pieces. There are front-end API servers that propose transactions, and those transactions then get forwarded on to a network of transaction validators. And then the transaction validators, and that's where the transaction validators validate transactions and execute any smart contract code. And then any transactions that pass validation then get forwarded on to what's called an ordering service, which takes transactions and puts them in order and generates a block, and then adds that to the blockchain. Now, the ordering service is the consensus piece, right? So that's where you get the different consensus protocols. Bitcoin uses proof of work, for instance, but Hyperledger distributed ledgers are designed so that there are strong APIs between each layer. So there's a strong API between the transaction proposers and the transaction validators. There's a strong API between the transaction validators and actual smart contract execution. And then there's strong API between the transaction validators and smart contract engine and the actual ordering and consensus mechanism. What's really cool about that is that allows us to make consensus pluggable, or it also makes transaction validation and smart contract execution pluggable. Hyperledger Sawtooth, for instance, supports not only the hardware-assisted proof of elapsed time consensus mechanism, but it also supports running the Hyperledger Burrow EVM, which is an open source implementation of the Ethereum virtual machine that can run Solidity contracts. So when you spin up a blockchain using Hyperledger technology, you encode in the Genesis block the configuration for that network. What transaction validators you're using, what are the cryptographic primitives, what are the signing keys for the transaction validators, the root key for the permission system, right, that then can enroll transaction validators and consensus nodes. And the neat thing is that as the blockchain goes on, you can also submit, you can set up rules for submitting new configuration transactions which change those values. So as the blockchain evolves, you can actually change the cryptographic primitives, which makes Hyperledger networks post-quantum capable. So at some point when we all decide that we have to move to post-quantum crypto, it would just be a matter of recording a new configuration transaction in the blockchain and then switching all of the participants over to the new post-quantum algorithms that are specified in that configuration transaction. You can also play around with different consensus mechanisms by swapping them out behind the API. Like I said, Sawtooth has POET, the Fabric has SBFT, and like Aroha uses one called YAC, yet another consensus. But we're slowly converging onto a common API across platforms, which would allow that different consensus mechanisms to be interchangeable. It also allows you to do an implementation of proof of work and plug that in if you wanted to. So, I mean, in theory, it hasn't been done, but in theory, it would be possible to do proof of work using Sawtooth and the Burrow EVM and basically recreate the Ethereum network using Hyperledger technology. But that hasn't been done because it's not been needed, right? Ethereum exists. The neat thing here is that it just makes our platforms sort of a configurable, customizable thing for your enterprise. I think that's why we have so many people from so many different industries interested, because like the Apache web server, there's a mod for that, right? Like you can just customize it for your industry and for your application and really leverage it to its fullest extent. I think we might have, well, I think we're up. I think we've reached the hour. I'd like to thank everybody for joining us. Marta, do you want to say anything right at the last minute here before we sign off?
I would like to thank you all for your questions. We'll try answering them offline. Would like to refer you to the next webinar on the decentralized identity, because we've seen a lot of questions about identity. And so though we can't answer them now, we hope that the next webinar will be able to answer them. Thank you for your time.
Thank you for mentioning that, Marta. Yes, we do have an upcoming webinar. Our next one on decentralized identity distilled will be June 12th. And if you check out the resources block in your webinar console, there's actually a direct link where you guys can go ahead and register for that today, just to get that on your calendar so you don't miss it. I just want to say thank you so much both to you, Dave and Marta, for this great session on blockchain security. And unfortunately, that's all we have time for today. So thank you all for joining us, and we hope to see you on another webinar soon. Bye-bye.